Hello, we're going to start actually working here in just a minute. Today we're going to be working on getting those multiple cameras. I rage quit yesterday, that sucked. So hopefully we can do a little bit better today. So let's see. Let's pull up what we basically need to do. So basically today we had this basic thing. So we need multiple cameras. So we need a 3D foreground camera today. So start by making that. And how we kind of plan on making that is we've got this line, which is our track, which our character runs on, and then behind it we've got this kind of screen that is the background screen, and then we got this foreground screen, and then we've got our isometric or orthographic camera that's going to kind of view the world like this. If our camera is right here, facing this direction. And we were playing around yesterday a lot with exactly how to set this up, and if we could do 3D objects that were interacting with the foreground and all that stuff. And then when I worked on it quite a bit, and we really didn't get anywhere. So hopefully, we kind of settled on basically that we can do a 2D 3D foreground and a 2D 3D background, but they need to be at like a 90-degree field of view. And the orthographic camera is obviously not a 90-degree field of view. And it's not necessarily a 90-degree field of view. It's basically, we want an actual field of view there to give it a nice sense of depth without having to make like 2 miles of foreground with such a low field of view. So today, that's what we're working on, is we're putting that stuff in there. So we're going to kind of hack it in there to begin with, using the scene capture components and all that. And then we'll stabilize it, we'll make it better. That's the plan. That's the plan, so stick to it. And again, these series are not tutorial series, they're more just documenting what we're doing with the game. And if anybody has questions, they can always jump on and ask me whatever they want, and I'll do my best to answer. You don't even have to ask about the game, just ask about, I don't know, anything. And it's all good. So let's just get started with a lot of these things. Because we did a whole bunch of work yesterday. We figured out how to do shaders for post-processing and all sorts of other stuff, and we found a lot of deficiencies in what we actually wanted to do. So what we're going to need 2 planes, which are lit by basically the scene capture test materials. And the scene capture test materials basically are just sampling the render target textures that we've got. I'm just doing their basic thing. So nothing too insane going on. Just making sure we actually got these all nicely set up here. Could not be successfully checked out, huh? Why do you not exist? Do you not exist? Alright, let's see here. Excuse me. Let's see. So we're gonna resize the render targets. Look into the show flags. We figured out how to do the show stuff. All right, so we need the 3D camera. We're also going to swap the axes globally so that we don't have to rotate our objects 90 degrees by default. Adam was getting pissed about that. And, well, if we're going to make that change, we should make it as early as possible in development. Let's see, this test content is not getting added here very nicely. So we're just double checking all the things real quick, just making sure that we have the correct things on everything. So scene capture test. And I was messing around with this like post-processing blend space stuff to try to make it work, and was just not satisfied that basically the render targets could be combined as easily as I wanted. So not the best. Alright, so we've got one scene capture actor, which is, where are you? Over here. And what we need to do is we need to make the foreground capture actor. Alright, and kind of how I was finding these things is these tags for the object. This is going to be scene capture cam foreground. We need a plane here. It's going to be this guy. And we need to assign the correct material to it, so it's going to be the foreground texture. And this is going to be scene capture quad 4. And what that should allow us to do is to grab that actual quad in code. Let's make sure we got things set up here a little bit. So we've got our capture component 2D, which is using our scene capture test foreground render target, which is scene color, inventory, opacity, and A. Composite mode should be so it should just overwrite the render target, no problem. Alright. Then we're gonna have to, for our 3D stuff here, we're gonna have to figure out exactly how we're drawing everything. And yeah, so let's start off. Let's make a couple of objects that are going to be drawn by our foreground camera. And we'll see exactly how they look. So let's just make a couple cones here of various sizes. So when we hit play, basically we can see, we're grabbing all the 3D objects and drawing them, and they're going in the background. And our foreground stuff isn't working, even though those cones are actually in front of our track that we're running on. They're being drawn behind. And that's because they're being drawn to the background texture, which is this guy over here. And this texture is getting thrown right behind this track, basically, nicely, and then drawn. So we need to not draw the objects and do all that. So I'm just gonna do that. So we need to go change our code to do all this. So, gosh. So we need to open up all the things and see how it works. All right, so. We need to first position the cameras all properly, so let's get started on that. Let's start breaking up these things into functions real quick. So it'll be like position cameras, position render planes. Because I was having trouble yesterday where I was just getting super frustrated and confused, and that's because I didn't organize any of this crap when I was working on it, and I just got frustrated because I was still working on it after so long. So what we need to do is open player proxy actor. And let's start making this a little bit easier on ourselves. And it is 7 p.m. on glorious Thursday? No, it's Wednesday. Yeah, this shows you how connected I am with reality. I don't even know what day it is anymore. So these are the scene captures. Scene captures are going to be our cameras. And then we've got our scene quads, and our scene quads are our planes. So what we're doing with our capture quads is we're going to set our scene quads and our scene quads and scene quads foreground. Maybe we should just call them foreground. Scene quads. And we'll be making this more efficient later. We need to just kind of make sure it all works to start with. So for all scene quads and all foreground scene quads, so today, place our background planes and place our foreground planes. And our foreground plane should go to our ortho near clip plane plus the tiny float. So basically it goes just inside our kind of orthographic box, which is like right here. So those will be the planes will be in the background and foreground. So we got that placed, and let's place our background stuff, or our foreground camera, that is. So foreground scene captures. So yeah, we're just basically placing those cameras exactly where our player proxy is, which is where our normal camera is. So we're taking the same picture, basically. So we're also going to we have to figure out which actors we need to render. So basically what we need to do is we're going to start off doing kind of some hokey stuff here, which is we need to figure out I would like to create a better method than this. Maybe Dashkin entity utils. Entity. Well, maybe not entity utils. It's kind of more just I want to know if an actor has a specific tag. So it's Dashkin game instance. So we should go change that. And add a new method in here that checks if something has a specific tag or not. I think that's a good idea. So we're just going to say like static bool actor has tag, you pass in, well actually we should be doing like const f names here, shouldn't we? And basically just an actor pointer. Alright, so const fname reference for that. This is one of the real easy things to do in C++ is accidentally write something that takes a fully qualified object as opposed to a reference or a pointer. You're just like, oh shit, whoops. So if the actor is null pointer, then we're just going to turn false. Otherwise, we're just going to do the little iteration thing. Just be like, for everything in the tag, and if tag is equal to tag. Yeah, that's a real smart plan. Let's just have capital and lowercase of the same frickin' variable name. So we'll just add our comment, which is iterates through all the tags and does a string compare to see if it contains said tag. So we shouldn't be using this except for like some basic debugging information. But basically what we want to do here is we want to say like bool add foreground equals false, add background equals false, and we want to do like if x is less than the minimum camera for an actor, then we're going to say like add foreground is true. If x is greater than camera max x, then it's going to be add background equals true. So we want a few things. So like if our Dashkin game instance, let's see, is it actor has tag, and we want to pass in like draw background, then we want to say like add foreground equals false, add background, well actually no, draw background should just be like add background is true, and draw foreground, add foreground is true. Do not draw would be like, you know, both of them are false. And then we want two more, which is like draw background only, draw foreground only. So draw background only, add background is that, add foreground equals false. And then we basically just have two things here. We have foreground actors and we have background actors. Because we can, our scene capture 2Ds, there aren't that many things you can do with the scene capture 2D, but one thing you can do is you can give it a list of actors to actually draw or not draw. And that's kind of a bit of a problem. We need to make it more efficient than that. And we want to be able to like change that to a set as opposed to a list. That way we can easily add and remove from it, and we won't have the same iteration problems. So this is going to be background, scene captures, we got foreground. And let's just refactor this just slightly to remove a few stupid things. And we'll be cleaning all this crap up. Alright, we need to check if an empty array renders the entire scene, and if we can add a null pointer to prevent that. Because one of the things basically is if we don't add something to these like show only actors lists, then I think it'll draw everything, which is not what we want. So what we need to do here as well is we need to resize those render targets to the screen size whenever the screen size changes. So we're gonna go ahead and do that. Let me see if this get all actors with tag. Let's see gameplay statics. Let's go to gameplay statics.cpp. I want to see if this resets the vector, resets the T array. Yeah, what does T array empty do? Empties the array, calls the destructors on held items if necessary. Well, that's kind of shitty. I would have liked this not to have just blown away the array that you pass in there. That way I can just call it again with the same array and it would just append to the end of it. So instead I'm just gonna do, because we're resizing them to the same size regardless. Let's just say resizing X number of render targets to %f by %f, and it's going to be scene captures.num and then window.x, window.y. So begin, play, all that stuff. So what aren't we setting here? We are not setting our near and far clips for our cameras. So the near and far clips for our cameras should be very specific. So I think that should be in begin play. We want to set up camera clip planes, clip distances. Because we're doing this inside of our update camera position is what it looks like, so maybe we should call that not in begin play, but we'll call it there. So we can just do this here, and we're going to need to grab our foreground camera and our background camera and set the near and far clip planes properly. That's the plan, at least. Alright, fine. Twitch doesn't want to load. I see how it is. It's like, no, I can't do it. I can't load that page for you. Fine. Fine then. Fine then don't. Then don't load the page. See what I care. Stupid internet. So what we need to do is we need to grab the foreground scene captures and the background scene captures. So we're not looking for the capture component 2D's target texture. We're looking for the capture component 2D's oh, we need to go to capture component.h, I think. No, I believe it's just scene capture component.h. Near, far. Max view distance, override. Sets the max render distance override can be used to pull distant objects from a reflection to reflection plane. Do we have a near clip override? Or just we don't? It is unfortunate that we do not have a near clip override. So we only have a far clip override. Alright, well. So the max view distance override is going to be the float, let's see, back. It's going to be, the distance is going to be the max x. This is going to be the well, the max view distance override is going to be like nothing for the background camera because it's just forever. But the foreground camera needs to have a, let's just say min and render box x is going to be the camera min x minus current position dot x. And that's going to be for foreground scene captures. And let's do max render box x is going to be the max x minus the current position. Of course, we're not using that. So let's just put like the min view distance for the foreground scene actors is going to be like, you know, 0 point. It's just going to be geophysics tiny float on that one. And for the background distance overrides, the max distance is going to be set to some gigantic number or whatever. And the min view distance is going to be max renderbox X. Anyway, so if we compile this all out, hopefully we coded all the hackery properly. We should get that foreground object properly at the front of our camera box. And it's going to be drawing, and the question is going to be whether or not it's transparent. Because if it's not transparent, then we will only see the front of it. And of course we have to pass in the actor for these things, so. And then have the proper number of braces for our if statements. Always important. Well, let's go see what happens. Let's see, so we've got our cones and all that stuff. Let's just double check. The sky sphere has drop background on it. The terrain needs to be drawn in, like, I think the draw foreground only, draw background only tag. So we can see our foreground object is drawing our 3 foreground objects. Our background object is drawing the sky and all that fun stuff and looks to be proper. But it doesn't look like it's getting scaled to the right place. But it's drawing what it should. It's drawing our 3 cones and it's drawing them where you would expect them to be drawn. So let's go take a look at the code that controls that. So it's not sized properly, so that's supposed to be, it's being positioned properly. So it's going to be, it's drawing the correct actors, set camera clip distances, those looked proper as well. So resizing, is it resizing right here? Yeah, resizing render targets should be working properly. Yeah, so it's going to be right here, this setup camera field of view. So we need to resize our capture planes to the size of the window in the world. So same thing here, basically scene quads should also include the foreground. Let's see, foreground. And we'll just do scene quads dot append foreground scene quads. So now we should see the foreground properly, and it's not transparent, it's what it looks like, so it's going to be black. Yes, this is what we'd expect, since it's looking like that. So what we need to do is we need to change our material, I think. So we've got our scene capture test foreground material right here, and it's set to opaque blend mode, and we should be translucent. So the opacity should be I think we want to just remove the component mask. Is that all we have to do? Or just throw our opacity right there? Can we do both? Can we just, does that work? Yeah, okay, there we go. And I don't like how our thumbnail thing doesn't save. At least it doesn't seem to. Like every time I reopen this damn thing, it uses a frickin' sphere instead of a plane like I'd like it to. So basically what this is doing is, I'll go over it a little bit more in detail right here. So this has a scene capture foreground, so it's a 2D scene capture component, and what that does is it's writing to this texture target, and we've configured it so that it's writing the scene color, RGB, and then the opacity, the inverse opacity in A. And when we actually go ahead and draw this out, it looks like, it looks proper, doesn't it? That texture looks good. So we just sample the texture, multiply it by our vertex color, and our opacity should be in the component. So let's take a look at what it looks like when we run it. Yeah, that opacity does not look right, does it? Looks like there's a little bit too much opacity in there. So why is it capturing the inverse opacity? Like, shouldn't it just be, can I just get the A? No, we don't want inverse opacity. I mean, why would it capture the inverse opacity? So now I have to like invert the frickin' opacity? So we have to do like 1 minus that, so we have to subtract. Yeah, and you can see these things are showing up as they should now. Alright, so we've got our objects, and they are floating in front of our scene. Cool. That's looking about like it should. So kind of what we'd want to do is we'd want to take these objects, and then we could move them around, so we could like move them real close up here. And then, you know, we're running past something in the foreground. It's big and scary. We could do the same thing here, where we take like maybe these trees here, and we can throw them in the foreground, make them like super big. Let's see what this will look like. I mean, obviously we're going to be hand making, you know, different assets for different parts of this, but if I throw something like right out over here, kind of like this, and then I hit play, oh god, there's just crap in front of the camera. But I think you can kind of see what we're going for here is we've got, you know, like this foreground stuff going on. So as we're running through here, we can have stuff in the foreground nicely, you know, obscuring what we'd want. I do not like how Unreal does not remember kind of what you were trying to do. It's like, you have to re-click on the object. Look, that's just a big blob of crap down there. No. But you can kind of get the idea of what's possible if we've got the foreground set up like so. Let's see, do we have any better assets than that? Let's take a look. Because maybe something would show this off a little bit better. What have I done? We're not positioning all of our planes properly. Come on, why do I have to reselect everything to get my frickin' axes back there? So yeah, you can see we got like kind of some foreground foliage coming across. It's moving at, you know, a different speed than the rest of this stuff. You know, it's only there as well when we're on the ground and all that sort of stuff. Of course, it's all pixelated and crap because it's not big enough. So we can actually copy it as well and maybe, you know, offset it a little bit. And we've got multiple layers of stuff. And the reason these guys are having problems is they're kind of Z fighting with each other in the render pass because they're too close to each other. So you can see now we've got like kind of a basic foreground, and if we jump up, you know, it nicely comes away. And in the hands of a capable artist like Adam, we can actually do a lot with this sort of stuff. In the hands of an engineer, I can just make it look like complete crap and anger Adam enough to actually do something to fix it. They're like, what's wrong with having cones? I'd be like, I hate you, I hate everything about you. So obviously what's going on there is we fix ourselves when we move, so we're not actually moving our cameras. So let's save all the things. And it's inside of begin play, I believe, is we need to call update camera. So it's, yeah, update the camera position, and that will update camera position should position our cameras and position our render planes. So let's make sure that we fixed our little bug there. It doesn't look like it's actually doing anything, does it? So begin play should get the current position. New position equals wanted position, transform set position. So we set up our actor transform properly. Set up our clip distances. Position our cameras. Position our render planes. So why is this like this? What happens the first time we move? Is it some sort of capture component thing? Capture on movement? Yeah, I think if we just turn off capture on movement, like it might be doing something stupid where it's trying to optimize something that we don't want. Create shown actors for render targets. Happens when we call position render planes, which we call an update camera position. Well, I guess we just start printing things out. It's odd that it fixes itself immediately. That screams of just some stupid edge case that we're not doing. Alright.